Yeah, in this session, we'll be talking about tuple in Python. So, what is a tuple? See, tuple is a sequence data type, but it is an immutable object actually. Basically, it's an immutable type. So, when I say immutable, the element once is assigned inside a tuple cannot be changed, okay, like a string in Python. Okay, if you compare with list is a mutable object. So if you create an object of type list, the content can be changed. Content can be changed. But tuple, even though it maintains index, okay, you can access the element one by one, okay, using subscripts, okay, like 0, 1, 2, 3, like that. Similar to the list, you can access the elements, but only the difference is it is immutable. Okay, the element cannot be changed. Right? So let us see an example of a tuple by going into our Jupyter notebook. So let me just create a tuple. I'll just say T1 is equal to tuple. Okay, fine. So tuple, either I can do this way, or what I can do, I can just do this parenthesis. I'll just say 23, 17, 19, okay, 21. And of course, the tuple is very similar to list. It can contain element of any type. For example, I'll just say ROM. I'll just say 23.8. I'll just say 5 plus 4j. Okay. I can have one more list as part of it. See 1, 2, 3. I can have one more tuple as part of it. See 10, 20, 30. Right. So you see, if I display T1, you can see here. Okay. This is called a tuple. Tuple starts with a parenthesis, ends with a parenthesis. And in between, you can have any element, any type of element, any type of Python element. It can be integer, it can be a floating point number, it can be a complex number, it can be another list, another tuple, string, anything. Okay. So if I just take the type of T1, look at this class tuple. So the class name is tuple. Okay. Now what I can do, I can use indexing to access the element of a tuple. What can I do? I can say T1 of 0. So that will give me 23. Okay, then I can use T1 of -1, which will access me the last tuple, subtuple basically 10, 20, 30. 10, 20, 30. Again, within that I can access an individual element. For example, 0th element, that will give me 10. Okay, fine. So the indexing, slicing, all are very similar to list and string in Python. But other than that, the tuple is immutable. So when I say immutable, so I can just say, I just go here, T1 of 0. Okay, I try to assign to 230. Look at this. So it says type error. What is the type error? Tuple object does not support item assignment. That means it is immutable object. It is an immutable object. So you cannot do this. You cannot do this. Right? So I can have a tuple and I can iterate over the elements of a tuple using any of the constructs which we discussed. For example, for x in T1, I'll just say print x. You can see here the elements are iterated one by one. Fine. So this we can do, and of course we can have other functions like I can concatenate one tuple with another tuple. So let us do that. The T1 is this. Okay, I will have T2, another tuple. T2, okay, will be 1, 19, 20. So what I'll do, I'll just say T1 plus T2. Look at this. See, it concatenates. So this operator, actually, this plus operator, when you call it, it is accessing internally. There is a method called __ add. Okay, that method is getting accessed. Okay, see, look at this. I'll just show you the method inside the help. See, help tuple. Okay, if you say help tuple, now I can just show you all the methods. See, basically, this is a constructor. See, this is a tuple. We'll have a constructor. iterable constructor. Okay, or you can say this way. See this method underscore underscore add. Okay, underscore underscore. This method is internally will be called when you access plus operator. Look at this, like this. See, when you do this way, na, T1 plus T2. Okay, when you call T1 plus T2, this method is called. Which method is called? This add method is called. This add method is called. Okay, fine. Then if I say, see, if I just go down, go up, and if I say, see, I'll just insert one more cell, and I'll say, okay, again 5 plus 4j, 4j in T1. It's true. Okay, so when I am calling in operator, na, this method is called contains method is called. Look at this, underscore underscore contains method is called. So any method which underscore underscore will be implemented based on the operator. See, plus operator is used for implementing this. Then okay, see, contains can be accessed using in operator. Then EQ means equality. Suppose if I say, look at this, I'll just say, I can just say, see, T2 is equal to, or I'll just say T1 is equal to T2 dot copy. I'll just copy it. Okay, fine. Sorry, T1 dot copy. This T1 dot copy. In fact, yeah, T1 dot copy is into T2. Okay, so T1 copy or copy object is tuple. So no, there is no copy as such. So what I'll do, I will just do one thing. T1 is assigned to T2. Look at this. Okay, fine. Now what I'll do, I'll just say T1 is equal to T2, or I can say T1, okay, double equal to T2. That will give me true. That will give me true, because both T1 and T2 they refer to the same object. They refer to the same object. Okay. Suppose if I have to refer to another object, what should I do? So what I can do one thing. See, I just say list of T1, okay, can be assigned to T2. Okay, tuple of tuple. Okay, now look at this. T1, T2, T1. I'll just print the ID of T1 and T2 and explain to you. ID of T1, ID of T2. They got different IDs. So what I did was, see, when I tried to assign directly, okay, I see, when I tried to copy it, I could not copy. But right now what happened, I converted tuple T1 into a list, and then I created a tuple from that list. That means I typecasted the list into a tuple. Okay, so you see, T1 is a tuple that was converted into a list. I got a list. Okay, that means T1 values are taken and converted into a list. In fact, no, using T1 data, a list was created, and that list was typecasted into tuple. So it will be a different object, of course. That is what you can see here. They got different IDs. Look at this, 248, 560. Now what I'll do, I'll just go here. Okay, I'll just check whether T1 double equal to, okay, T2. T2, we can see here, it's true. See, even though, look at this, even though T1 and T2 are different tuples, because IDs are different. IDs are different, but they contain the same data. Okay, suppose if I say T1 is T2, I'll get false. Look at this, it's false, because T1 is a different object and T2 is different object. Even though the contents of these two objects are same, they have different identities. Okay, that is why T1 is T2 gives me false, and T1 double equal to, that is, when you say double equal to, no, it invokes EQ function. True. Okay, both contents are same. Suppose if I say T1 not equal to T2, okay, I'll get false. Look at this, I'll get false, because both the contents are same, so I'll get false. Okay, so see, all these underscore methods can be accessed using the shorten operation. You see, greater than equal to, GE means greater than equal to. I can just say, I'll just say something like this. I'll just go here and just say T4 is equal to, give a tuple 1, 2, 3. T5 is equal to, I'll just give 4 comma 5 comma 6. I'll just say T5 is greater than or equal to T4. I should get true. Okay, look at this. True, because here I got 4, 5, 6. The element, it goes comparison by element. The first element is 4, second element is 1. So suppose if I do this way now, in that case also it's true, because the first element, okay, the corresponding element, okay, out of which T5's element is greater than T4's elements. So T4 greater than or equal to T4, so T5 greater than or equal to T4 will be true. Otherwise, suppose the T5 is less than or equal to T4, it should be false. It's false. Fine. If you say T4 is less than T5, it should be true. True. Fine. So see, this operator less than or equal to, they are accessed. Okay. When you call, see, these functions in fact, less than or equal to will be invoked. Okay, for this particular function. LE, greater than E, LE. Okay, length will give you how many elements are there. For example, if I say length of T1, 9 elements are there in T1. Suppose you see T1, I'll just show you T1, print T1. You can see there are 9 elements. 2, 4, 6, 7, 8, 9. 9 elements are there. Okay, so tuple, I think we have discussed about the various methods within tuple. Okay, and then it is an immutable object, so you cannot make changes, okay, or add element into a tuple. That's not allowed. You cannot add as you add in a the list. See, you look at this. Say I try to say my T1 it is. I'll just say T1 dot append or something like that. Now, if I try to give, okay, no attribute called append, or even if I cannot give add, no, you cannot add. Okay, because tuple is an immutable entity. It's an immutable entity, so you cannot do that. Okay, fine. So, tuple. Okay, of course, the only similarity between tuple and list is both the data structures or both the data types can contain elements of any type, and it's a sequence type. That means indexing starts at 0, goes up to 1, 2, 3 like that. Then you can do slicing. You can do you can traverse forward direction, reverse direction, anything you can do. Okay, fine. But you cannot change. You cannot add element into your tuple. Okay. Sometimes we may get elements result which should not be changed. In that case, you go for a tuple. But suppose if you want element to be changed in a tuple, convert into a list, then you can change it. Okay. For example, you see, I have like this. Okay, I can convert a list into a tuple. How can I convert? I'll just say import random. Okay, then what I'll do, I'll just create a set of random numbers, some 10 random numbers. Okay, using list comprehension, I'll do it. I say my list is equal to, put a square bracket. Okay, just say x, not x. I'll just say random. Okay, random dot rand int. So I want to generate numbers from 50 to 100. So what I'll do, 50 rand int 50. Okay, let me just check it first. int of 50. Okay, so rand int, sorry, missing required a positional argument. So 1 to 50. Okay, so I got 38. I got 38 right now. Okay, I got 38. So it should be 1 to 58, 51. Suppose I want element to be between 51 to 100. So in that case, what you can do, you can just add 50 to this. That's it. Look at this. Now see this random.rand int will generate a number from 1 to 50. But we don't want 1 to 50. We want 50 to, okay, or 51 to, okay, 51 to 100 I want. In that case, what you can do, you can just say plus 50 if you give now. This will generate 1 to 50. Suppose if it generates 1, you'll get 50 plus 1, 51. If it generates 50, you'll get 50 plus 50, 100. So this is a method you have to follow. So these are techniques actually. These are techniques. See, 101. Okay, 96. Fine. So if you put 49, you'll get, I think, 50 to 100. Look at this, 88. Yeah. Sorry, 49. If you get 49, look at this. You'll get, if you get 49, you'll get 50 to 100. Exactly. 100. Okay, fine. So using this, I want to generate a list of numbers. So I'll put my list is equal to, I put a square bracket. This is a number for x in range. Range what? I'll just say 10 random numbers. Okay, so I'll just say range 1 to 11. Fine. So look at my list. Print my list. You can see here 2, 4, 6, 8, 10. So for x in range 1, 11 means 1 to 10. 1 to 10. That means, so this for 10 times, this random number will be generated, which will be between 50 to 100 and stored inside my list. Okay, fine. Now if I have to convert into a tuple, so what I can do, I can just say my tuple is equal to tuple of, okay, my list. That's it. Okay, then I'll say print my tuple. Okay, look at this. It becomes a tuple. So tuple cannot be directly, okay, created. So what we are supposed to do is we can create randomly a list and then convert this into a tuple. Fine. So these are the ways you manipulate tuple, okay, data structure. Hope this session was useful. We'll meet in the next session with some other interesting topic. Thank you.